Hello, everyone. Welcome to our second series in our cybersecurity webinar. We hope you're taking really good care of yourselves. Thank you for taking out the time to join us for this session. Before we formally begin our presentation, we would like to thank you all for the incredible response that you've shown to the webinar series and our previous sessions. For those of you who are new here, I'd like to open this session with a brief introduction to INTECH. So INTECH is a system integration and automation solutions company. We've been in the industry for over 30 years. We have extensive OT and systems background. We have 13 offices around the world, and the industries that we primarily work in are oil and gas, upstream, midstream, downstream, petrochemicals, utilities, and power generation. So over these 3 decades, we've done thousands of projects and we've completed over 2,000 engineering man-years. We also have a dedicated digital solutions group that offers digitalization applications and OT cybersecurity solutions. And we have our panelists today who are people from the digital solutions group. So our panelists are Ahmad Baig, who has over 15 years of experience in the OT space. He has leadership in OT risk assessment. He has multiple certifications for cybersecurity, and he is the group manager for our digital solutions products. Also with us today is Mohammad Imran, who has over 2 decades of experience in IT and OT cybersecurity. His experience is in framework, risk management, policies, processes, and procedures, governance, and compliance. So I'm just going to give you a brief overview of the agenda we'll be covering today. We'll be developing some rationale and discussing why we need standards. Then we're going to jump right into the standards. We'll start with the ISO 27001, the NIST Cybersecurity Framework, and IEC 62443. We don't have time to delve into other standards. These are the most important standards for OT cybersecurity and building context. After that, we'll discuss some rationale for choosing standards and how we work with them. And we'll briefly touch the minimum security capabilities and components you need to build an efficient cybersecurity program. So let's start with the prerequisites, and I'm gonna invite Ahmad to tell us what he can about prerequisites and why we need them.
Hi, everybody. So thank you, Emmett, for giving me this opportunity to speak on a large forum. And so the best way to approach a problem in this case of cybersecurity is to identify what kind of needs the organization has and what kind of scope are we going to address. And then there is another context of an organization where we talk about the prevalent systems, if there is a framework which is existing in that organization, addressing the IT needs of security, or is it something which we are establishing from the very start? So we're starting from scratch. So both of these contexts have to be kept in mind when we talk about frameworks. The common philosophy that I would always recommend, and that we have listed down some of the key concepts here, is that it's a top-down approach. Cybersecurity is not a light matter that can be taken lightly by any of the organizations. There are several incidents that have happened recently in the industry, and they impact both the OT assets as well as the IT assets. So with the advent of integration of the systems with IT systems, the IoT environment, and the IIoT environment, we must realize that the buy-in of the leadership is quite important whenever we design a framework. The leadership can consist of CEOs, CTOs, the CISOs, the CDOs, the directors of the security in an organization, the asset owners, the risk owners, etc. And this is based on the size of the organization and the context of the organization itself. The leadership has to identify the right people that have to be included in a certain level of the program. Eventually, we must consider these three factors. Whenever we are designing a framework, there are people, there are processes, and there's a technology factor. And there is a certain level of investment in each of these factors. Maybe no one factor is more important than the other one. So we talk about establishing the goals for that organization as well. So from the very beginning, we must identify the objectives, the scope of the cybersecurity framework, identify the systems. Typically, in terms of the 62443, we call it the scope under consideration. It should be clearly marked that what is the extent of the security controls that we are going to implement. Establishing the context of the organization is also very important. By context, we mean that we must understand the environment where the organization is operating, what kind of threats are there in that environment, who are the threat factors and the groups which are trying to target different kind of facilities in that country or environment or the region. So establishing the context is quite important from the very beginning, and bringing that realization to the leadership is important. Then based on our experience, we've seen that if we don't establish clear goals, clear roles and responsibilities of the personnel who have to run this program, and the change management strategy is not in place, then the way that we operate and the way we run this framework is not going to be a success. So based on our experience and the way that it works, establishing clear roles and responsibility from the very beginning is going to be quite important. And then finding a way to implement the change by using the framework, and outside the framework, using the existing philosophies and policies has to be there. The last step, once we establish all of these prerequisites, is going to be your thought process about how to select the right framework and the right fit of for that organization.
Okay. So before we just start going into the standards, can you tell us why do we need standards, just to like set some groundwork and how they're related to OT specifically?
All right. So, okay. So one of the things that we always say is none of the standard is one size fits all. There's always a need analysis and a risk analysis based on which we have to take certain kind of controls into consideration, and certain kind of controls which do not need to be implemented have to be taken out. And those controls correspond to certain level, certain type of frameworks, right? So frameworks are a living document. They are built by using the industry knowledge and the feedbacks provided by different security organizations, industrial organizations, standards organizations, and regulatory bodies. The goal is common. Like we know the goal is to improve the cybersecurity posture of the organization, cybersecurity posture of the industry in that region. So the goal is common, but still we need to identify the needs based on the context of the organization and the systems we are trying to address. One common example we can take is the terminologies of IT are quite different from the terminologies of an OT system. There is no sensors, there are no actuators. You don't talk about the DCS systems in an IT environment. So to overcome these kind of shortcomings in different standards, there are a variety of standards and regulatory requirements in place by the governments as well.
Okay, so let's jump into the standards themselves because that's what everyone's here for. And I think as a good starting point is ISO 27001. Of course, this standard has been around for over 2 decades. It's the leading standard for IT cybersecurity. It's pretty mature, and it's got significant implementation across multiple organizations. So how is 27001 related to OT cybersecurity?
Right. So considering the maturity of the standard itself and the extent that it has been implemented, one can say that it may be applied to all types of organizations. And the specifications require us to establish certain kind of requirements, implementing those requirements, operating those and maintaining those requirements once they have been implemented, and reviewing and maintaining, and then further improving those cybersecurity management requirements. The strength of ISO 27001 lies in documentation, procedures, and management systems because it has been matured over time and it has a lot of learning from the industry in the IT domain. On the other side, it's not built for OT environment. So uh, just implementing ISO 27001 in our context when we talk about OT systems is not practical. So you have to have a combination in mind that how to implement or extend an already established ISO 27001 based cybersecurity framework into an OT domain. Another name that we usually use for ISO 27000 based framework is the ISMS system because it is an information security management system. And the terminology which is being used for these OT systems, cybersecurity, is the CSMS systems, which is the cybersecurity management system. Not a huge difference, but we must understand the context and the way they have to be applied. The so in OT environment, we use a combination of we can it's quite easily implementable that use a combination of ISO 27001 with the NIST standard or the ISO or IEC 62443 standard. You can see there are four phases in the life cycle of the ISO standard. The purpose of all of these frameworks and the ISO 27001 is to make it repeatable and to make it
implementable and consistent over and over again. It's not a one-time activity.
So continuous improvement.
It is a continuous improvement. So you start with the plan phase, you define your scope, establish the context of the organization, you do your risk assessments and gap assessment, select the controls which are aligned with the existing policies, and then extend those controls to the OT environment when we talk about the OT security. So not directly implementing those controls, but you can map, or you can use an umbrella standard to map the OT controls with the IT controls in the organization. That ties with your change management procedures. Then you go for implementation in the do cycle, and then the check cycle is primarily to validate the extent of the controls and the security measures that we took. Are they effective? They can be audited internally or externally, and that feedback can be used to further improve and correct any kind of procedures or policies and the controls that we establish initially.
I think one thing that we should point out here is that the controls we implement from IT to OT need to be inherently different, because ISO 27001 defines your control based on a CIA model, right? So it's confidentiality, integrity, and availability. But in OT, this model changes into safety first, and then availability, then integrity, and then confidentiality. And that requirement just changes how you look at different controls and how they treat your OT systems, because your OT systems are interacting with the physical world. So safety becomes the first priority. You cannot lock your operators out of the systems if there's an emergency or an hazard or something like that. So that's absolutely philosophy for OT
absolutely control. Right, Ahmed. So we say, and we know it, that the ISO standard is just meant for the IT world. It does not address the terminologies even which are coming from the OT side of the table. So very rightly said.
So I think it's natural to then transition into the NIST cybersecurity framework, which of course includes IT as well as OT systems, and it has multiple parts in it, including the NIST 882, which is exclusively for OT controls, and then 853 and 39. So what can you tell us about that?
So just one thing to remember when we talk about ISO 27001, before we transition into NIST, I would say the risk perspective is based on financial loss, reputational loss, and somewhat with the personnel as well. But the focus in the risk perspective, when you are measuring the risk in ISO framework, is either financial related or reputational related, and that's for the IT based systems, right? And when we talk about and we transition into the OT environment, the risk factors are going to change, because you mentioned the cyber physical world where you can interact with the physical systems and you pose a risk to the security and safety of the environment, safety of the people. And whenever you have to realize the extent of the risk, you can just imagine that having bad control of cybersecurity in an OT environment can impact the life of a person. So there's no more, you cannot put a number on that, and you cannot justify any, lack of controls in that kind of environment. So the risk is quite high. So coming to NIST now, so we have just mentioned three, SPs from the NIST 800 standard here. Primarily, we'll talk about 882. And just to give you a background of the NIST started developing the standard, the CFS standard, based on the US Department of Defense requirements. And they started establishing the CFS along with the private sector and the public sector. And they worked together, they did multiple workshops, and they did a lot of brainstorming to come up with the standard. They utilized ISO 27001 life cycle in developing the standard. But fundamentally, the NIST 882 is an operational standard. And, if you look at the life cycle of NIST, it is quite different. It just goes down to the business. If you go to the next steps, you'll see that it directly goes towards controls and implementation. It is more operational standard, and framework and lifecycle is more operational rather than
ISO, which is very theoretical, that you plan and then you do and then you check. So NIST is just starting with identify and protect. So there's
so it goes down to the business and talks about how you need to protect, right? Another interesting aspect here is that it allows you to select your own controls. Although NIST has established the standard specifically for different critical infrastructure and industries, but generally they don't enforce it. So they let the asset owners and the industry owners to select their own controls based on their own risks. Right. So 882 particularly, the purpose of this document is to provide guidance for securing the ICS systems, supervisory controls, SCADA systems, DCS systems, IPS, SIS systems, fire and gas systems, all the industrial systems. The documentation basically addresses the architectures, the risk management philosophies, identifies the type of threats and the type of vulnerabilities that exist in these systems, and then put together a set of controls which can help the industry to protect these systems. And to help this 882 standard, there is another standard 853 which was established to basically align the NIST framework with the ISO framework. And there's a lot of commonality.
The ISO 27001.
Yes, ISO 27001 framework. So there's a lot of commonality between these two frameworks as well. So there's a way that you can map, and even NIST has provided a point-to-point and a control-to-control mapping in their documentation, how to utilize and transition from one framework, ISO 27001, to a NIST 853 framework. So they're both addressing the security needs of the IT environment as well. And by using the combination of the NIST 882 or the with the 27001 or 882 with the 53 would be a good way to move forward when you're talking about your framework enhancement and framework development. Naturally, if you have a NIST 853 established in an organization, then you want to use 853 in combination with 82 rather than combining it with another standard, right? The differences, like if we talk about the differences between the NIST 853 from the ISO 27001 differences, like as a simple example, we can take as a business continuity and management system. So when you're evaluating the business continuity for an IT system, it's primarily focused on the IT infrastructure and the business continuity from the billing systems, your SAP systems, your ERPs, like the systems which are related to your business continuity. But in terms of the OT, it becomes an operational impact analysis. So your business continuity management is focusing on operational technology. So how to improve the production, how to improve the redundancy of the systems, what kind of controls are there to improve and increase the reliability of the system which are in place. So the standard has typical terminology, but the focus is a little bit different because of the systems we are considering. The third the SP or standard procedure in the NIST, which is 839, is primarily aligned with the ISO 27001 from the risk management perspective, because the 53 and the 82 does not give you a risk management cycle or life cycle. So that one is primarily there to help the organization to establish a risk management framework along with their cybersecurity practices and frameworks and controls.
Okay. So since we're talking about OT controls and IT, I think the next thing we need to discuss is a standard that's exclusively built for OT systems, and that's the IEC 62443. Now, this standard was originally made for manufacturing facilities, processing plants, disparate utilities, and disparate assets as they're found in like oil and gas upstream production or in pipelines. But it has been adopted recently across different industries as well. And now this is an interesting thing is that this standard doesn't just address the asset owners themselves. It also includes system integrators and product manufacturers. So how would you go about explaining 62443 for us?
Right. So, okay. So just to, again, link this standard with the prevailing practices in the industry, because a lot of organizations already have prevailing systems which are based on either the NIST standard or the ISO 27001 or even their own regional standards, right? So what we propagate is to combine ISO 27001 or IEC 624 with the 62443 in the case where there is a prevailing system. In some of the organizations, we have seen that they tried to implement the 27001 by extending that directly over the OT domain, but that was not really a successful experiment. So here, IEC and ISA 62443 series explicitly addresses the issues such as the patching management, the antivirus management, the specific issues which actually come up in case of the OT environment.
Encryption restrictions, things like that.
Exactly. So the way we look at the systems in an OT environment is fundamentally different. Even the terminologies, as I mentioned, are quite different, right? So 62443 explicitly is built for this purpose. And when we go towards the 62443, ISA and IEC, they joined hands. The Committee 99 of the ISA, they are primarily working with the IEC body to establish a common standard across the Europe and the US and the other regions of the world, right? 62443 takes a risk-based approach. And another key difference in this case is, which is based on the concept that it is neither efficient nor sustainable to try and protect all assets just by one standard. So it gives you a specific standard for the OT environment, and the organizations can use it in combination with their IT standards to expand it over the whole supply chain and whole of the organization. The 62443 series is basically distributed in 4 parts. The different parts are general concepts, the policies and procedures, the system-related parts, and then the components-related parts, right? The first part, which is the 3-1-1, actually defines the terminology, the concepts, and the models for the IACS systems, or you can say the industrial automation and control systems. The 1-2 includes the definition and terms and the acronym. So these are the bases to explain how the standard can be used by any of the parties, whether they are asset owners, system integrators, service providers, product manufacturers, or suppliers, and to harmonize the understanding of everybody. Right. The second part is the policies and procedures, where 3-2-1 specifies the asset owner security program requirements for an industrial automation system or IACS system, and provides the guidance on how to develop and evolve the security program for that organization. So it talks about the maturity levels, the SL levels in case of IEC 62443. The 2-2, which is basically used as the measuring methodology for maturity of the organization, is still under evaluation, is still under development. Then the third part here is 3-2-3, which talks about patch management. Like it's a surprise that you see a specific chapter just regarding the patch management, specifically because the patch management philosophy in IACS systems is fundamentally different from an IT system. If you are a user of IT system, you'll know that it's happening in the background. You never notified, and maybe sometimes you get a notification that your system has been upgraded overnight and you're just sleeping and systems are being updated.
Yeah, most of the times you come in the morning and it says your system has been updated.
Yeah.
You didn't know it happened.
Right. So in case of OT, it doesn't happen like that. So you have to plan your updates, you have to plan your patches, you have to test those patches on a regular basis. And before going to implementation, which is a big step because there is the risk of outages in your OT environment, you have to make sure that these kind of risks does not happen. Then the asset owners and the operators and the instrument techs, so the stakeholders which are actually working on those OT systems, they have to be taken on board. The stakeholder management is quite important. Then the change management has to be run in a way. So the standard is very extensively explaining that how to manage these patch management, and develop the framework for the patch, just for the patching activity. Similarly, there are practices which are defined in 3-3. I'm not going to jump to the 3-3, but just to keep in mind that 3-3 covers the other fundamental requirements which are needed for securing these systems. 2-4, however, specifies the requirements for security capability of the ISCS providers, like companies like us and companies who are providing the project-based organizations who are running projects for automation systems, on behalf of the asset owners. So moving on, 3-1 is something which is a system related, right? It provides a current assessment of various cybersecurity tools which can be used in that environment. I mean, this is also another topic which you cannot apply directly in an IT environment. So fundamentally, IT is quite simple to work with. If you're using certain tools in an OT environment, just for network exploration, that is something which can cause trouble in your network, and your network can choke, and it can affect your production capability or safety of the environment. The 3-2 establishes requirements for risk assessment in order to partition the IACS systems into zones and conduits. The concept of zones and conduits is also quite important in the IEC 62443, because fundamentally they are the ones who establish that how to define the zones and how to define the conduits and how to define the risk levels on a zone and conduit, because that lays the basis of risk assessment based on IEC 62443 for the OT system. This terminology is very specific to the 62443 in this case. Then the 3-3 is the one which I was mentioning, that it shares and provides fundamental requirements. So there are 7 fundamental requirements that it talks about, which talks about the user access management, patching, endpoint security, data confidentiality, restricted access of the data from the secured systems to the unsecured systems, etc. So that's something that we can talk about later on in another topic. The last component is related to primarily to the product manufacturers and suppliers, which talks about requirements for the product developers. These products coming from the IACS systems, and the 4-2 specifically talks about product manufacturing and requirement for the embedded devices like network components and host components and software applications, etc. So life cycle of the secure development life cycle is addressed through the component related part here.
But I see that it's also keeping provision to cover the advent of IIoT and Industry 4.0 components as well.
Definitely. I mean, this is something which is really coming up in.
Okay, so let's move on and let's just discuss our rationale for choosing the standards we work with. And we're going to open this up with a small report we found in the SANS ICS OT Cybersecurity report for the last quarter. They asked their respondents which standards they work with for their control systems, and nearly half the respondents work with NIST Cybersecurity Framework, and then around 30% of them work with the combination of 62443, NIST 853, 82, and ISO 27000. So how do we justify our rationale for choosing and working the standards that we work with?
Right. So this analytic is quite interesting. So first of all, it shows and reflects that these organizations, they're not using one standard. So they're using a combination of the standards to gain the overall controls and overall cybersecurity posture improvement. However, at the same time, when we recommend the rationale to the customers and the organization that we work with, we look at their current systems in place, and we want to harmonize with their existing policies and procedures. We want to harmonize with the existing practices. We address some of the lessons which we have learned in a hard way, that change management is really important, right? So we talk about the governance practices which are enforced by the government and the regulatory bodies. So we have to align with all these aspects, and then we make a smart choice. And it has to be a risk-based choice. Like it's not something which can be on the go. It has to be based on what kind of risk exists, what was the gap assessment, what kind of context is in the organization. So primarily, the prerequisites are also a defining factor in when we are choosing our one of the standards, right?
Those prerequisites could be other standards as well, for example, quality, manufacturing, project management standards, all of those which apply.
Absolutely. Just to mention here, the OT safety standards, the TUV standards, also play an important role in this overall posture and improvement on the safety systems, cybersecurity measurement.
So speaking of other standards, we asked our experts and we gathered a list of the different standards that we worked with in the regions that we work in. And these standards are compared to ISO, which is a certifiable standard, or NIST, which is an opt-in standard. Now, these regional standards are mandatory for a lot of the regions where they work in. And so, Amat, what can you tell us about which standards out of these have we worked with?
Just keeping in mind the time limit, I'll say that we have to keep in mind that the regulatory bodies, they have their own goals, and they have an objective which is just bigger than the industry or the customer we're talking with. Right? They want to improve the overall posture of the overall country or the region and the overall industry prospect. So KSA has established ECC, which is Essential Cybersecurity Controls, under the body of National Cybersecurity Authority, which dictates on network connected systems that how to improve the posture of those systems. And whenever they're going for an investment, it provides them a rationale of choosing the right kind of investment on their technology part. However, at the same time, these do not dictate you how to manage the people-related aspect and the change management aspect, right? So you have to be careful when you're going for these kind of implementations. However, eventually the goal is the same for all of these standards: to improve the security posture, to improve the industry posture, to improve the organizational posture.
Okay, so I think that just brings us to the last topic that we're going to be touching, and that's minimum security capabilities you need to establish a cybersecurity program. So
all right,
I'd like to address this.
So here we have categorized these into two kind of capabilities. So primarily, there's a combination of non-technical capabilities with the technical capabilities, because eventually the decision has to be based on the risk-based approach, right? Some of the common practices and essential practices have to be that we must be able to measure what is the current posture, what is the current security standing of that organization, and how to keep it measurable and manageable on the long run. So we establish the KPIs, we establish the risk management philosophy for a certain organization, and then we talk about physical security. Now, physical security can be technical, can be non-technical, because it starts from your HR, from induction of an employee in an organization, and it ends where the employee has left. And even after the employee has left, there are certain type of controls which have to be taken care of. So from that aspect, uh, from the access management system aspect, from the CCTV aspect, there are several aspects which are physical security control related. Even asking somebody by developing a procedure when they're entering a facility can be part of your physical security. That's why they want to access a certain system. So keeping logs, keep monitoring, regular monitoring of those logs, that who access which system at which time, is quite important, and it's considered under a non-technical control. Incident response is another important non-technical and a combination of, you can say, technical control, where you must have systems to look at the type of incidents that could happen and monitor the behavior of the organization. And behavior management, tabletop desktop, tabletop exercises for foreseeing an incident and then responding to that incident is quite important. So that comes under incident response. Governance policies and procedures and compliance aspect has to be established in an organization, which we are trying to address by developing a framework, right? Eventually, if we talk about in general, we have to be aware about the type of risk factors and the attack vectors which could exploit your organization. They could be internal, they could be external attack vectors, they could be supply chain related. So by saying that these are the minimum security capabilities, we're trying to say that we are meeting a certain baseline, right? And but this is just a minimum control line. You can have a different environment with the advent of Industry 4.0, IIoT, combination of the VR and the AR. Even your data security will change, right? So if you're talking about data security and OT security, that will also naturally change, because you have the cyber physical systems which are there. The type of impact that it could bring to those systems will have adverse effects. So just be aware about your surroundings and the risks that are existing in that environment. According to the context, we must choose these security capabilities and security controls.
So it's an interesting thing that we're closing this webinar on the topic of risk, because our next session is going to be on a risk-based approach to OT cybersecurity implementation and application of controls. It's going to be around in a month's time. So I'd like to open up the floor for discussions. If you have any questions, you can. Sorry about that. If you have any questions, you can type them in the chat, or you can raise your hand to ask that question. And we already have a question already. The question is, how do you define safety levels versus tiers in 62443 and NIST cybersecurity framework?
So this question by itself, it would take like a full webinar to address. But on a high level, the 62443 has defined security levels which have to be studied and established based on the zones and contours study. So different, or based on the architecture of the systems, you can have different zones. You can have a DCS zone, an IPS zone, a UCP zone. You can have a generator zone. You can have, so multiple zones can exist in a single architecture. And not all of them have the same level of requirement of security, because you can have network connected systems, you can have non-network connected systems. Based on that, we say that we establish a security zone requirement, and then we assess that security zone requirement is met up to a certain level by measuring in terms of the zone 1 to zone 4, the safety level 1 to safety level 4. And then we say the target level is based on the risk that that zone can bring into the picture. So the target level is what we want to achieve for that particular zone. And so all of these zones and contours have to be assessed based on these as SL levels, and then establish a policy for that particular zone. So your investment decision and your controls decision will vary from the criticality of the risk from that zone to zone. Now, this was related to the zones and contours and the SL levels in IC 60443. But for the NIST, where we talk about the tier-based approach of cybersecurity and maturity, now NIST allows you to choose your own controls based on what is existing and what is the target level. So similar to the SL philosophy, but it is based on a flat network approach. And you have to have an approach based on overall organizational architecture, right? So that's the fundamental difference. And then your controls will be applied at a flat level of that particular architecture or particular area which we are talking about. Fundamentally, these are a bit different, but the goal is the same, to improve the security posture.
Okay. So we have a question from Emmanuel, who's asking if these standards are available to study.
Yes, so 62443 is also available. It can be actually purchased from the ISAFE body or IEC. There are 5 chapters which are actually published at the moment. The rest of them are under discussion and they're going to be published soon. Then the NIST standard is open, so anybody can go and check the NIST organization and they can download that standard. 882 is open.
The whole framework is open.
Yes, 53 is there, 39 is there. They are still available openly.
So, we have another question, which is, what are the most common issues you face in the way of generating a buy-in for implementing an OT cybersecurity program?
All right, and another tricky question. We know that now basically what kind of threats are there, and every day we are hearing about some new threats, vulnerabilities, attacks which are coming up. The recent one which got a bit popular was the Log4j. Which has been there for a long time, and nobody realized that this vulnerability existed in the system, right? And now it has been patched. Similarly, there are many incidents that are happening, and they're getting a lot of publicity out there because they pose a reputational loss, they pose a financial loss to the organization. So similar kind of, if I talk about an incident, you can talk about the impact of Colonial Pipeline. It impacted it was carrying about 2.5 million barrels per day of the fuel across the pipeline. It's one of the largest pipelines in the Northern American region. And it impacted more than, say, 40%, I heard.
And around 40%.
40% of the population got impacted. There were long queues on the petrol stations. The flights were stranded. They were delayed because of the shortage of the supply of the fuel. And
people started panic buying as well.
People started panicking. And the interesting thing is they even paid the ransom. Yeah. Right. So they paid the ransom. They couldn't restore the systems, and it originated from an IT-based vulnerability and weakness in the organization
system, I believe.
Actually, it's somebody stole the credentials of an employee which left the organization, and they got sold on the dark web. And the person who bought from the dark web the credentials, they used it to access the VPN-based, access for remote access for the employees, and then got access to the system. Yeah. So that's something to bring the awareness to the leaders of the organization. Most of the organization leaders, they are already aware of this. This is a growing threat. I believe nobody can say that I'm not aware of the threats that the cybersecurity poses. Maybe they're not aware about the OT threats, the difference in OT and IT threats, but this is something that we can bring by increasing the awareness and knowledge overall in the industry.
Okay, are there any other questions? We're actually also out of time for our session, so let's just see if there are any questions or any hand raises. I don't think there are any. So I think let's close the session up, and we'll be back in another month for our next session for our risk-based approach to OT cybersecurity. Thank you, everyone, for your time. Thank you, Ahmad and Mr. Imran, for your participation in making this session successful. Have a great day, everyone. We'll send you a link to the recording for this session, and we hope to see you in the next one.